Hey guys, welcome to Skill-Lync. The digital revolution, which began around the 1950s to 1970s, shifted the use of mechanical and analog technology into digital technology. This began with the invention of the computer, which could store data and perform mathematical calculations. This age was called the Age of Information. The change from analog to digital communication was done because digital signals use packets of compressed data to send information. This was considered to be better than analog signals because these packets of data were considered to experience less interference in the received signal. Digital communication plays a very vital role in our lives today. In this video, we'll be learning about how digital communication takes place. Let's go into the schematics of how a piece of information is transferred through digital communication. So, let's consider this block diagram. This can be divided into two parts, the transmitter and receiver. The transmitter sends the signal while the receiver receives it. The various components at the transmitter end consist of a source, an input transducer, a source encoder, a channel encoder, a digital modulator, and then a transmitter. From this transmitter, the signal goes to the channel. Let's say that you're at the source end and you need to send a signal which can be an audio or video or even an image. Now, let's see how this message reaches the person at the other end. The signal will be first converted into an electrical signal with the help of a transducer. This signal will now be transferred to the source encoder. At the source encoder, the signal is converted from analog to digital form and compressed to a minimum number of bits. Source encoding the signal ensures that the bandwidth of the channel is effectively used as it compresses the data into a minimum number of bits. From here, the signal is passed on to the channel encoder. At the channel encoder, redundant bits are added to the signal. This ensures that even if parts of the signal is lost during transmission, it is not necessary that the message signal gets lost entirely. This helps in data protection. After this, the signal is modulated. Modulating a digital signal provides higher data security to a signal and helps in improving the quality of the signal. Modulation can be done by three methods, namely amplitude shift keying, frequency shift keying, and phase shift keying. Phase shift keying is further divided into binary shift keying, quadrature phase shift keying, and differential phase shift keying. After the signal is modulated, it is sent via the transmitter to the channel. From the channel, the signal is received at the receiver antenna. While the data is being transferred through the channel, there are chances that it may encounter unwanted disturbances called noise. And once the signal is received by the receiver, the reverse process of what occurred at the transmitter takes place. The signal is received at the receiver, and after this, the signal is demodulated. The high-frequency carrier signal, which was mixed with the message signal at the modulator stage, is removed. The signal then passes to channel decoding. Here, the opposite process of source encoding occurs, and the redundancy is removed from the signal. From here, the signal is passed to the signal decoder. At the signal decoder, the signal is converted back to its original analog form. The output transducer finally transmits electrical signals to its original form, and the receiver receives the message. This is how digital communication takes place. Well, that's all for this video. We'll see you in the next one. Till then, bye.